All right, so we are looking at articulations this week. We're looking at joints. Articulations is another word for joints. And so we're going to look at the first dozen slides here. Now, one of the slides that is not here, I should say, is joint classification according to movement, according to function. And there are three, and I'm going to write them over here to the side, or write the first letter for it. We have the syn articulation, diarticulation, amphiarticulation. The syn means it is not movable. Syn means false joint. Arthritic, I should say, synarthritic. Amphiarthritic are ones that are slightly movable, and this kind of means it's so-so. And then the last is diarthritic, which means freely movable. And you can remember that it makes you sad that you have to remember those. Synarthritic, amphiarthritic, diarthritic. Now, I'm not going to go through them much more than that. It's pretty, that's not a question I'm going to spend a lot of time on any of this. There might be one question about it on the practical, and I'm not even sure that that's going to happen. But synarthritic, syn means false, and so, or a lie. Synarthritic, arthritic means joint, so it's kind of a false joint. It does not move. Amphiarthritic, something named amphi means it's so-so. It's not one thing or another, like an amphibian. It goes from one thing to another, water to dry land, whatever. So it's so-so. Amphiarthritic means that it's slightly movable. Diarthritic means that it's freely movable. So the real thing we're going to look at with joints is the classification by structure. So we have three types. The first one is called fibrous joints, and that's what we're looking at here. It is fiber that holds the two joints together. Now, the only one that I'm really worried about as a fibrous joint is this one right here that we learn as a suture. We've all had to look at these so far. So sutures are going to be generally the joints of the skull, and they look like sewings. That's why they're called sutures. So I definitely want you to know a suture is a type of a fibrous joint. That's the main one. Now I'm just going to tell you this one just because I like it. Gomphosis. This is a joint where the periodontal ligament holds the tooth in that little socket, and so it is called a gomphosis joint. It's and you can remember that if you lose this joint, you lose your tooth, so you have to gum your food. And so I always think that's funny, and I try to throw that in there. But honestly, fibrous joints, suture is what you need to know and stick with. Then cartilaginous joint. I hope that you don't really have to study too hard in understanding that in a cartilaginous joint, it is cartilage that's between the two bones. And so there's two types. One has hyaline cartilage, again, the most common type around, and then another is called fibrocartilage, and that's the tissue that's stained really blue and red ocean. Now, I want you to know both types of these, all right? So the first one is called a synchondrosis. Again, syn means false. It's kind of like false cartilage. This one lists this first, the cartilage for the first rib. That's not what I would test you with. It would be this one right here, because when we get into the skeletal system, you will learn that there is this little growth plate called the epiphyseal plate, and that is going to remain hyaline cartilage until you become an adult, usually around the age of 20, 21. That will solidify, but while it is still considered the growth plate, that is, I'm going to have a bone, and then I'm going to have cartilage between the diaphysis, the epiphysis and the diaphysis. This is going to be a little plate of hyaline cartilage between those, and that is a synchondrosis joint. The other one is called a symphysis joint. Now, The basic joint here, and now symphysis joints are going to be fibrocartilage. The synchondrosis joints are going to be hyaline cartilage. The fibrocartilage is going to be found in two places. One of them is called the intervertebral discs. The other one, and the one I would probably say is going to be really good to know, is this little band of fibrocartilage called the pubic symphysis. It says so right here, pubic symphysis. Now, if you can remember that these bones right here are the two pubic bones, and this little joint between them is called the pubic symphysis, it tells you everything you need to know. It is a symphysis type joint between the two pubic bones. All right, so hopefully that helps. Now, again, not really big into any of these, not going to get too crazy with them, but fibrous joints, definitely know sutures are fibrous joints. Cartilaginous joints, you have two types. Synchondrosis, which is the epiphyseal plate, which we commonly call the growth plate, and the symphysis joint, which the main one's going to be the pubic symphysis. That one's made up of hyaline cartilage. But the one we're really going to study the most is this thing called synovial joints. Synovial joints are all freely movable, but these are the joints that we generally think of as a joint. Now, this little picture, I've got a bone on one side meeting and moving against a bone on the other. All right. Now, there are some complicated things, but we're going to stick fairly straightforward now. First, each bone is going to be covered with this cartilage that we have learned called articular cartilage. The articular cartilage is hyaline cartilage. Again, if you've eaten a chicken drumstick, you got that little nasty piece of cartilage at the top, that was articular cartilage. Now, in a synovial joint, what's going to happen is I've got this bone and I've got periosteum on the outside of it. All right, over there here on this bone, I've got periosteum on the outside of it. Well, as the periosteum gets close to the epiphysis, as it starts to form this joint, the periosteum is going to attach with these fibers that extend out and attach with the periosteum on the other bone. This is called the fibrous capsule. It is the outside of the total capsule called the joint capsule. The inside is called a synovial membrane. Now, where the fibrous capsule is synonymous or continuous, I should say, not synonymous, continuous with the periosteum, the synovial membrane is continuous with the articular cartilage. The articular cartilage will change and you'll have this little membrane that goes around it forming a little balloon, and that is called the synovial membrane. All right. Now, inside the synovial membrane is the joint cavity, and it is filled with synovial fluid. So those are the parts of the average synovial joint. In lecture, and maybe some in lab, we'll talk about meniscus and bursae if I get a chance, but right now we're just worried about these little structures. So we're going to look at how we organize synovial joints into 6 basic types of movement. And I'm going to tell you what the classic example is. All right, so the first type is called a ball and socket joint. It is probably the easiest of all of them to recognize. It is your hip joint. It is the acetabulum, that part of the coccyx, and then the head of the femur. That is a ball and socket joint. Now the shoulder, the head of the humerus, fitting into the glenoid cavity is one too, but it is not anywhere near as perfect of a ball and socket as your hip joint. Then we have what's called a condylar joint. So this is the one we kind of talked about, how a condyle is a raised part of a bone, and then on the opposite side you have what we generally call a fossa. Well, these condylar joints, the best ones that are pure condylar joints, are going to be your knuckles. This joint in particular is called the MCP joint. So it is called the metacarpal phalangeal joint. It's where the metacarpal meets the phalanges. All right, that MCP joint. That is a condylar joint. And I'd just take knuckles if I asked about it anyway. Then we talk about the plane or gliding joint. Again, both of these it can be called either one of those. These are going to be in the carpals and the tarsals. These are where the bones are actually going to glide against each other on distinct planes. And so they kind of just, like if I took two bricks or two things that are smooth and you kind of can move them back and forth on each other, that's kind of what we're talking about. They glide along certain planes. But it would be carpals would be the ones that I would tell you to remember. Now, the ball and socket, which we said was the hip, is pretty classic. The next, probably most classic, is called a hinge joint. This is absolutely demonstrated as the ulna and the humerus, that little part that we looked at in lab where we talked about the ulna having that little hook part to it, and how we call the one part the olecranon process, the one part called the coronoid process, or coracoid, and then we have the trochlear notch in the middle, and how that fits into where that humerus had those same things, only called a little different, and it forms this hinge on it. The elbow joint is a hinge joint. Now the last two, a pivot joint. The pivot joint, the classic example is atlas axis, where that dens sticks up and it fits into where the body of the axis should be, and it forms a little pivot point. That is why axis is called axis. It is the axis of rotation, or the pivot point. And then finally, the saddle joint. This is a real interesting one. It is at the base where the metacarpal of the thumb articulates with the carpals. It forms this little saddle joint. It is what allows us to have opposable thumbs and to be able to grab things. Now, one way that I say that's pretty easy to remember this is one of the reasons I remember it is when I was a kid, we moved from Chicago to a little town in Mississippi called Tupelo. It was a big culture shock. I was only like 4, so I don't remember much of it. But my parents brought my two older brothers horses because they thought it would help them adapt. And well, the horses were, one was very wild. And so I remember getting on the back of it, or my dad putting me on the back of that horse holding on to my brother, and the horse wouldn't go. So my dad, who knew nothing about horses, which, by the way, if you don't know anything about horses, you really shouldn't be around them without someone who does know. So he thought the way to get the horse to go is to slap it on the butt. And so I remember I held on to my brother and that saddle for dear life as that horse went through the field, jumping like we were in a rodeo. And I got a little injured here and there, but it was all right. But it was my saddle joint that helped me hold on for dear life, so I could remember the saddle joint is what allows us to have opposable thumbs. Now, the next set of these are going to be joint movements, and I'm going to tell you that I'm going to kind of point some things out on it, but I'll really talk about this while we're in lab to go over it. But remember that when we look at joints, they're going to at least, or movements here, they're going to at least be paired. Now, in your, you might want to look and see in your book, they will describe these joints. And sometimes it's good to have a description of them as well. For instance, flexion extension. Now, this is going to show flexion extension at the knee. You could do it with the elbow. It's fine. Flexion is decreasing the angle of a joint. So if I have my arm out and I bring my hand closer to my shoulder, the angle of my elbow has decreased. So that's flexion. Extension is the opposite. It is increasing the angle of a joint. So I stretch my arm back out. There is one, this is the only one that really has this third part to it called hyperextension. And the only place we really see that is the wrist under normal conditions. And that would be if I have my wrist, if I have my palm facing up, and I pull my palm towards my hand, or my forearm, that's flexion. I extend it out to 180 degrees, that's extension. But the wrist can go past 180 degrees, and that's called hyperextension. Now, I'm not worried about lateral flexion. And I will talk about abduction and adduction. I'm going to mispronounce that that second letter to make sure we're good with that. Abduction, abduction. If I abduct something, that means I take it away. So down here on this one, you can kind of see they're using the hip again. Abduction is when my leg swings out, or if I'm using my arm, if I'm standing up and my arm's down by my side, and then I raise it up to shoulder level, straight out. That is abduction. It's been abducted. Adduction, add, means to bring things together. So adduction is when things come back towards midline. So it's moving away or towards midline. Dorsiflexion and plantar flexion are both dealing with the foot. The top part of your foot, oddly enough, is called the dorsal surface. The bottom part of your foot is called the plantar surface. So if I point my toes up to my shin, so it's like I'm walking on my heels, my toes are pointed up, that is called dorsiflexion because there is flexion of the dorsal surface. If I point my toes down, like I'm walking on my toes, it is called plantar flexion. Circumduction and rotation are ones that are a little bit odd. What I'll tell you is if I have a axis, a point of rotation here, rotation is if I move around that axis and stay on the axis. So let's say I stick my hand out, straight out at my shoulder like it's pointing out to the side, and I rotate my arm, but I don't move it like I'm making circles, like you see this guy in this picture that he's doing circumduction. But imagine my arm's out here, and there's this little point of rotation sticking straight out, and I just rotate my arm back and forth. Because I never leave the axis of rotation, it is called rotation. Circumduction, which I'm going around the point of rotation while never being on it, is called circumduction. If I had the globe here, and I'm trying to draw, this is, all right, I don't know, that doesn't look like the globe. But if I have the globe and I am spinning this globe around, like this is a globe, like something you'd have on your desk, there's a rod that goes through it, and which is called the axis of rotation. If I'm spinning it, since it never leaves, it's called rotation. Now, if I'm looking at the Earth, and I have a satellite up here, the space station, and it is circumducting the globe, that means it's going around the globe but never being on it. So circumduction means turning around without being on it. Medial rotation and lateral rotation I'm not worried about. Supination and pronation all deal with the hand. So if I have my hand out like I'm carrying a bunch of logs and my palms are facing up, that is called supination. Now palms facing up, when I was in school, I had a professor that talked about if you were begging for soup, your palms would be up, which I just think is weird, but it's one way to remember it. What I would tell you that is there's a directional term, which I think we should talk about more, but we don't. If I am laying on my back, right, and I'm facing up, that is called laying supine. Now, if I'm talking about laying supine, what I'm saying is I, not you, is laying on my spine, supine. Well, that's where this comes from. Supination means palm up. The palm is the face of your hand. And so palm up is supination. If I was to turn around and lay face down, that would be called laying prone. And so when my palm has been turned face down, it is called pronation. That's where the two words come from. And the last couple of them, inversion and eversion, this goes into what we would probably think of a lot of times in ankle injuries, a sprained or strained ankle. Inversion means the inside of my foot is pointing medial. Eversion means it's pointing lateral. If I have an eversion to something, I want to push it away. Now, in ankle sprains, almost all of them are going to be inversion ankle sprains. You step on something and you roll your ankle, and they can be really bad. The few that you'll see that are eversion ankle sprains, if they are bad, if you have if you evert your ankle enough to cause it to be strained, in general, you are going to break that fibula. Just a little FYI. Then we have protraction and retraction. Protraction and retraction means you're sticking something out. Protraction means I'm sticking something out. It could be my head, it could be my jaw. Retraction is pulling it back in. And then finally, elevation and depression. Elevation is raising something up. Depression is pushing it back down. If I was using my jaw, my mandible, easy way to remember it, if I elevate my mandible, it closes my mouth. If I depress my mandible, I open my mouth. And you can remember that a lot of times when professors open their mouth, it can cause depression. Ha, 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 ha. Anyway, that is those are the parts of the articulations.